how's it going? Have you ever thought about creating your own project? Something useful, something where you are your first customer. It's not about getting revenue or creating a global company that influences government. Just something small and cozy, like a pet project. Let me introduce myself. I am Vladimir, or just Vlad. Kind of an unusual name, isn't it? I'm not a native English speaker, and that's where my pet project idea came from. While reading books or watching videos, I often come across unfamiliar words like this or this. Sure, you can use Google Translator to understand them, but I forget those words in 10 seconds. You should know what I'm talking about. What does this word mean? So I decided I need a coach to help me repeat these words, making me smarter and more attractive. And here is it, my Telegram bot. This bot helps me translate words and when I have time practice them to keep in my memory. Are you interested about how to turn this idea into reality? Today I'll show you how to leave Google without money, how to memorize a goose, and how to create a useful Telegram bot. So to be an effective language coach, it has to have two base features. Translate words and practice words. Looks easy, I thought, and then I ran into challenges. Everyone loves challenges. Challenge 1. Quick to use. I didn't want to open the browser or wait for the application to load just to translate a word while watching video subtitles. I need something seamless, so I decided to use a messenger bot. We're all chatting on messaging apps all the time, so having my coach bot in my contact list made perfect sense. Since my preferred messenger is Telegram, that's where I started. Challenge 2. Cost efficiency. Next, I wanted to make the bot as much cheap as possible. There is one Tibetan wisdom: if you want something cheap, do it yourself. It's not always true, but it worked for my bot development. So I choose my homey development stack, it's Golang and Postgres, and coded it by myself. The simplest way to implement the app was to use an existing API. These APIs provide translation, transcriptions, descriptions, synonyms, everything you need. However, they can be quite expensive. Here are some prices for 1000 words. Google costs $3.2, Microsoft 1.6, Amazon 2.4, and DeepL costs €1. While some of these services offer free tiers, we can further reduce costs by maintaining our own dictionary. Here is how the translation algorithm works. So the user types a word. We check if the word exists in our translation database. If not found, we request translation from an external service, save the result into our database and return it to user. Next time someone requests this word, the translation is retrieved directly from our database, eliminating the need of additional API requests. Challenge 3. Scalability. I prefer creating extensible application from scratch. It makes more time initially but allows you easy implementation and testing of new ideas as the project grows. Here is how the bot's architecture is structured. API layer. It handles all client data processing. It might be HTTP clients, bots, or other external services. Service layer. Manage core logic, including translation, practice rules, and checks. Repository layer. Manage data storage and retrieval using Postgres. And third-party providers integrate external services seamlessly. This clean and extensible architecture allows us easily add features like browser interface, switching to a NoSQL database for our dictionary, or integrate different translation services without changing the main logic. Learning techniques. There are many effective techniques to transfer information into learn memory, such as games, quizzes, puzzles, and even AI-driven speech recognition. But how long would it take to implement all of that? Let's focus on the most efficient way for everyone: repetition. Oh yeah, boring repetition is one of the most efficient ways to study something new, including new words. So we start with a simple repetition algorithm. The app displays translated words in a loop and asks users to translate them. Easy to implement, gives positive results, exactly what we need. So I implemented a translation Telegram bot filled with default dictionaries using Golang and Postgres, with an extensible architecture and a simple repetition algorithm. Let's dive into coding now, but not too deep. I don't want you to practice retyping today. I just want to show you the basic concepts I've used to build this application, so you can implement the same in any coding language you prefer. The logic for working with bots is pretty much the same as with HTTP clients. Users communicate with the Telegram app, which sends requests to the Telegram server. The server forwards these requests via long poles or WebSockets to our server, and we send responses based on those requests. Here's how Telegram sends requests. Via standard message, here user types something to the bot and the server receives an event. Inline keyboard, when button is pressed, predefined text is sent to the server. Callback button. No text is sent here. So here are the handlers I'm using for my bot. Starts. So it's first user communication. It stores new users into the database if they don't exist, and sends a welcome message. Choose a dictionary. It's inline button command that lets users select which dictionary to use. Practice mode. Sets bot to the practice mode where regular messages from users are evaluated instead of translated. End session. So it ends practice session and shows summary to the user. Regular message. In translation mode, translates the word. In practice mode, evaluates the answer. In our bot, certain user interactions are handled via callback queries. We can take a look into the callback methods and how parameters are added to them. Set dictionary saves the user's dictionary. Practice select saves the practice dictionary, and practice handles practice menu callbacks. Here is an example. The parameters source len and target len are appended to the set dictionary prefix when creating the inline keyboard buttons. When user selects a dictionary from the inline keyboard, handle set dictionary command method is triggered. We use a switch statement to map the selected option to the source and target languages. The user's preferred dictionary is updated by calling update user dictionary with the extracted source len and target len. A confirmation message is sent to the user to acknowledge that the dictionary has been set. Next, let's review the application logic. We have three main services: user, practice, and translation. User service. It can get or create user, it update user dictionary, it update user mode, and get user language pairs that have been used. Translation service. It's basically translate words. Simple logic, right? Here we implement the translation logic using external services as discussed earlier. Practice service. The practice service is responsible for managing practice session, evaluating user responses, and updating user progress. It interacts with the repositories to fetch and store data related to users, words, and practice sessions. Start practice session initiates a new practice session for the user. It checks if the user already has an active session, creates a new practice session with the user's ID, practice direction, and start time, saves the session in the repository. Get next practice word retrieves the next word for user to practice. It fetches the active practice session, gets the next word based on the user's practice history and direction. It adds the word to the session words practice lists, update the session in the repository. Evaluate user response. It evaluates the user's answers and provides feedback. So it retrieves the active practice session and the current word being practiced. It increments the attempts count to the current word. compare the user inputs with the correct answer using helper methods, updates the session statistic like total words, correct answers, it updates the user word review data in the user word repository using a spaced repetition algorithm, and returns feedback indicating whether the answer is correct, almost correct, or incorrect. End practice session ends the current practice session and provides summary. Calculates the total duration and accuracy of the session. Compiles a list of mistakes made during the session. Updates the session's end time and saves it to the repository. Returns a summary with total words practiced, correct answers, accuracy percentage, and duration. Get current practice word. Retrieves the current word being practiced. Get correct answer method provides the correct answer for the current practice word, and helpers method for normalizing and finding exact and fuzzy matches. An essential part of the practice service is the implementation of the simple spaced repetition algorithm. When a user practices a word, the system tracks how many times they've reviewed it. Review date is set based on the review count, increasing the interval each time the word is correctly recalled. After the first correct recall, the word might be scheduled for the review in 1 day, then 2 days after the second, and 4 days after the third, and so on and so on and so on. Which helps move words from short memory to long memory efficiently. The practice service is functional, there is always room to optimize by adding more sophisticated space repetition algorithm like SM2 used by Anki. They could improve learning efficiently, or including richer media or gamification elements could make the learning experience more enjoyable. Now let's check how I structured the database using Golang, which is an ORM library for Golang. I defined several models to represent the entities in our application. Practice session DTO. This struct stores information about the user's practice session, including the words practiced, the number of correct answers, mistakes, and timestamps. Translation DTO. This struct represents a translation entry in the database by storing the word, its translations, and the source and target languages. User word DTO. This struct links users with words they have practiced, tracking how many times they've reviewed a word and when they should review it next. Then I defined repository. Translation repository handles finding and creating translations. User word repository, it manages the word associated with the user for practice. And user repository deals with user data. For even faster read operations, especially if the dataset becomes substantial, we could use a specialized search engine like Elasticsearch or key-value store like Redis. However, implementing these optimizations adds complexity and requires more development time. For this initial version, I prioritize getting a functional prototype up and running. I've postponed these upgrades to the next release for future us. Once the coding part is done, there are 2 simple stages left. The deploy our bot to a server and set up the bot on the Telegram using BotFodder. In my case, I used AWS EC2 for deployment. After everything was set up, I could enjoy my pet translation bot. I named it PhrasePopBot, the first free name available on Telegram that I found. I didn't spend too much time on branding. The image is AI generated. After starting the bot, we got the basic description. For instance, I got a new Spanish word el ganso. Let's select a dictionary and try to translate it. It's a goose. Let's try another one. Perro. It's a dog. Later in the evening, I want to practice words. I press practice, select the dictionary I've used, and here we are, translating dog to perro and ganso to goose. Of course, you can try it too. It's completely free to use. The link is in the description below and somewhere here. Guys, I hope you enjoyed this video. Please write the comments what languages and features you would like to see in the future bot releases. Share what you don't like and, of course, what you would improve. Subscribe to the channel and stay updated on the new bot releases and much more related software development. I appreciate your time. Have a good one.